I'm Brian Blackburn. I'm the Chief Technology Officer of Redox Power Systems. I'm responsible for the entire design of the cube, all related technology, component design, and the base cell technology. I'm working with the university and all our suppliers and scaling out all of the technology and basically getting this thing to work.
Okay.
The cube is a 25 kilowatt power generation system based on clean, efficient, solid oxide fuel cell technology that was developed by Eric Waxman over 25 years. The system has a very small footprint, about 1 meter on each side, and then it sits on a 1 foot base. So in total, it's about 4 feet tall, 3 feet across, 3 feet deep, and it weighs under 750 pounds, which is a comparable system might be several thousand pounds. Runs on natural gas and puts out secure, efficient, reliable generation. That's what we call it, power surge. Nickname's the cube. It's this shape of a cube, and inside are stacks of the solid oxide fuel cells, which resemble cubes. So that's why we call it the cube. 5 kilowatt generator might power a house. This would power an outlet mall. Yeah, 25 kilowatts could do a strip mall. And they can be ganged together to give more power. So 4 of them gives you 100 kilowatts. The heart of the system, the cube, is right here. These are the fuel cell stacks. It combines multiple cells and boosts the power. And there are room for as many as 32 stacks in this system. Right now we aren't going to need that many to get the 25 kilowatts. And also something to note is the size of the stack. We've just recently shrunk it by 60%. And it's going to mount 90 degrees from where it is now. So we open up a lot of room in the middle where we can improve the system later on. So this is air intake in the front. There's natural gas connection in the back. The air and the natural gas are preheated before it gets to the solid oxide fuel cell, because the solid oxide fuel cell operates at an elevated temperature. There are in the back fuel processor unit, which sort of breaks up the natural gas coming in to make it a little easier to turn into electricity by the fuel cell. And then the preheated air and pre-processed and fuel come to the stacks, which then take those reactants and generate electricity. The green lights indicate that everything is okay with the system. Should something go wrong with a stack, for instance, or some other portion of the system, a signal would be sent to the command center where the cubes are monitored and would alert the maintenance crew. And the lights would turn red to indicate various problems with the system, so that the maintenance team comes to fix it. They immediately know what the problem is. Sort of a diagnostic signal. So if this little cube here turned red, it would indicate that this stack went bad. One of the advantages of our system, it has very few moving parts. There's only one that I can think of, the compressor for the air that comes in, which is basically just there to push the air to where it needs to go. And so there's practically no vibrations. Combined with the lack of vibrations and low weight and size, these systems can go on rooftops, such as in New York City, for cell phone towers and backup power generation should power go out. Some of the sort of efforts that allowed us to shrink the size of the stack were some manufacturing breakthroughs with our partners that also reduced the cost. So you have reduced size, weight, and cost. All of the things which allow us to sell this at a lower price in the competition and at the footprint and weight that we are targeting. Opens up lots of doors for different applications. such as stationary power, military, mobile power, cars, anything where you have power, basically. Wouldn't necessarily be in this package, be a different product, but there's a lot of flexibility with what we can do with the individual piece parts, modules, stacks, that basically make the applications limitless.